And today we'll be talking about encapsulation and polymorphism. But I'll be dividing the video into two. So we'll be dealing with encapsulation in this video, and the next video will be polymorphism. So first of all, encapsulation in C# or object-oriented programming is a process of enclosing data in a class into a physical or logical package. So what do I mean by that? So if I have a class in C# and I want to restrict some access to the fields and the methods in the class. That process itself is called encapsulation. So, and how do we implement that? We implement that by using some access modifiers or access specifiers, such as the public keyword, or we can use private. We have the protected, we have the internal, we have the protected internal. So, without further ado, I'll just go ahead and create a class, and then we go into the coding aspect of it to explain more of how it works physically. So, for example, let me see. We can have a class called rectangle class. Okay, so of course we know that rectangle has a length, it has a width, it also has an area. You will need to like calculate the width and the length of the rectangle to get the area. So I think that should be a perfect example to work with. um so in the rectangle class itself, I will first of all start by defining the properties of the rectangle using the public access modifier keyword. So we can have something like a public double length, public double width, right? Okay. Oh, my bad. So that should be at in the class level. Okay. So, and of course we also need to get the area of the rectangle. So we'll create a method itself. Public double get area. Right. Of course that will be like the area of a rectangle should be length times width, right? Okay. We can also have even an extra method that will just display it, so we don't need to like type a lot in the entry point method. Okay. So we can just display that. We can give it like length. We can just copy and paste that real quick. So the other one is width, right? And the other would be like the area. Just call the get area method. Okay. So now I will go into the main class and try to access this. So the implementation here is we declare a variable for length and weight using the public access modifier. Okay, public. I want us to focus on this keyword. So if I go out here in the main class, then I instantiate the rectangle class. Right? So if I click on if I type the R object, rectangle object, to get access to the rectangle class, so you can see I have access to the length, to the width, and to the area, get area method, and the display. Right? So I can assign something to the length like 4.5. I can assign something to the width like 3.8. Then I can call the get area. I can just call it display because in the display itself we have implemented the get area. right? So if I run this code, yes, of course it will run. Okay, so let's run it and we'll see that how that goes. So since it's a public access modifier, so it gives us access to it. Length is 4.5, weight is 3.8, and the area is 17.1. And we basically have access to that because this is public. What if we change these access modifiers to a private type? So let's see what happens in the other class, in the outside class. You can see the squiggy red lines. So it says that rectangle length is inaccessible due to its protection level. So it means that whatever access modifier we assign to a variable or a field in a class, so it is not exposed to an external class. A class outside of this class cannot access this because it has been restricted to a private type, right? So that is more like uh, implementing abstraction in a class level. Remember, we talked about abstraction in the other class, which is more hiding other classes from other class. But in this case, we are implementing abstraction inside of a class. So we don't want users to have direct access to this data here, right? But we need the user to actually input their own data, and their own data will be compared with what we have here and then implement it. So they wouldn't have the direct access to it. So how can I get access to this data here? Basically, what I can do is I can create a constructor in the class itself to encapsulate it. One of the things I can actually do is, let me see, I can go ahead and create a constructor. So in the constructor itself, I can assign a double value here. Then I will need to bind this data here into here with the private value. So we can go ahead and do something like then so that way uh, I would be calling the constructor from the outside class here. So here I'll need to be calling the constructor. This constructor will be requiring me to be putting in the length and width out there. So I can have user to enter it here like double width equal to 4.5, double length equal to, let's assume 8.7. So first of all, I'll need to clear this out, clear that out. Then I would bind this user input into this constructor, right? Okay, there we go. Because the constructor here in the rectangle class, we've already binded that here, right? So that works like that. Or better yet, if I don't want to go this way, I can just create a method that requires users to input the data itself. I can have something like public void accept data, right? So that way I can explicitly have the user to input data console.write. So the user will be requested to enter a length, then the length, the private length here, we're going to assign that to whatever the user has input there. Okay, I think this is probably the most efficient approach. That way we can work with users' data, whatever user input. Then enter width Java dot double. Okay, yeah, I think that's much more better. So, and then it will calculate it here. So let's see how that works here. So we're not even using constructor again this time around. Clear that up. And so we just need to clear this up and just call the accept data method, which is the object.accept data. Okay, so that is going to call this method and it will trigger the user to input their own details. So let's run it and see how that works, and we can go from there. I think that is pretty much better. So it's requesting for user to enter length. Let's put like 4.5 there. Enter width. Let's put like 3.5 there. Or we can put 4. Yeah, 3.5 is fair enough. Okay, so it says length is 4.5, width 3.5, area 15.75. So that's basically encapsulation. So the main idea there is like here we don't have direct access to the length, right? So you can see we don't have direct access to the length and width like we did previously when we are using public. So here we no longer have direct access to it. It's been encapsulated. So we created a method that triggers the user to input their own data in there. So that is basically how encapsulation works. It keeps the raw data away from the users by using the private access modifier, right? So we also have protected modifier, which actually restrict the access to only the child class. So if another class inherits triangle, if I use protected here, so it is only a class that inherits triangles that will have access to this data. And we also have internal, which is the data will only be accessible by only the classes in the same namespace. Okay, and we also have protected internal. So you can play with all these things, and they also have their own usefulness in real life projects. So basically, that is the idea behind encapsulation, and that is how it works. In the next video, we'll be talking about polymorphism. Thank you, and I'll see you in the next one.